Welcome to Shop Talk. This is Keith. I'm here today with my best friend Bob.
Hey guys.
For those of you who might not be able to tell, we're not live. We're pre-recording this kind of as an experiment. Was I supposed to talk about that? Quit taking your pulse, Bob. But in any case, before we get going today, I want to remind you October 4th and 5th. That's the first Friday, Saturday of the month. We're going to get together here at the shop on Friday, starting at 10 in the morning till 2 in the afternoon. We're going to have our first annual Bob's CNC family get-together.
Food.
Oh, God. We have all kinds of good stuff coming. We've got really good. We had pastries here a couple weeks ago that were just unbelievable. So we're going to have a whole mess of that kind of stuff. We're going to have barbecue for lunch. So anyway, bring your appetite. We've got an RSVP date of September 6th. We need to know if you're coming so that we make sure we have all the refreshments that we need. That's going to last till about 2 in the afternoon. And after 2, we're going to break down and head to Springfield to Ozark Technical College and set up for the Maker Faire. And if you can help us, we'd love to have your help getting stuff over there.
Bringing the truck, yeah.
Oh, and you're probably going to bring your truck because you're bringing all kinds of projects that you've been working on.
Absolutely. Rated G projects.
Yes.
Not even PG-13. We need them rated G.
No, they need to be really family friendly. We've got 900 square feet that we would love to fill up with your stuff. So please bring it along. Oh, and along with that, I've got an announcement that I can't make.
Yes, you do.
That is really frustrating.
It is.
I bet it's frustrating for you too, but when you hear it, it'll be worth it.
We can't even do this live because he was all,
I was really pumped. Yeah, and you were going to cut it out.
Yeah.
Okay. Well, anyway, the topic we're going to talk about today has to do with engineering, and it. Yeah, I know it. And it has to do with plywood.
Are you leading it?
No, because it has to do with engineering. The reason I wanted to talk about this for a long time.
He talks about it a lot.
Well, I do. It ticks me off. Well, I got not customers. There are people in CNC forums that know more about CNC than I will ever know. And guys that have experience in shop and all kinds of stuff. But they make rude comments about plywood construction in CNCs. And so I wanted you to address kind of the history of why we do what we do, but also I wanted you to talk about the engineering side of why we do what we do. Now, for those of you that don't know, Bob and I have worked together as carpenters. We both enjoy woodworking. I think Bob's a much better woodworker than I'll ever be. But, I built cabinets, I built desks, no Chippendale furniture, anything like that.
Actually, he's got pretty nice furniture.
No,
Actually, the reason I got into CNC woodworking is because I'm not that good. I need a machine to do it.
Yeah, well, anyway, we're going to talk about the intarsia work you've done a little bit later.
Okay.
But why would anybody build a CNC out of plywood?
I guess, I'm going to take this from maybe 3 different angles, right, to help out. So the first one is because of what you just said. We're carpenters. So, we're not metal workers. We're not machinists.
Right.
Not even anywhere close. But we are carpenters, maybe. Well,
I'm retired.
Yeah, okay.
Kind of.
And our customers are, right?
Yeah.
And believe me, I'm always amazed at some of the things that I see that people do because I'm not that good. The artwork that our customers put out on our Facebook is just awesome.
Yeah.
But so the first answer is we're woodworkers. That's what we know. That's what we have tools for. That's how we do things. So of course you would design it. The second for me is probably more personal. I love simple, cost-effective designs, and I wanted to get something out there that other people could have experience CNC like I do. And in order to do that, you have to make it as cost-effective and as simple as you can. And
which also implies dependable.
Oh, right? Absolutely, yeah.
Okay.
Yeah, we could get into that. Maybe we'll do that as another discussion about reliability versus the number of parts, but not for today's discussion.
Okay.
But so simple, cost-effective, get it into as many customers' hands as you can, so that people can experience the joy and the fun of woodworking with CNC tools like you did. But you're not really interested in that. You really want to know the engineering behind it, and we've talked about this probably until one of us is blue in the face. But we're going to go over it again on camera. So behind us, Kristen will pop up the linear back and forth deflection, just deflection, right? But for this one, it's for a simply supported beam. And again, there's this one basically covers a beam that's simply supported. We did a video showing that less than a year ago. You can go out on our YouTube and watch me go through it again. But we're just kind of going over it really quick and really fast. But deflection, we want it to be small. We'd love it to be 0, but there's no way in the world it can be 0, because these all have numbers that are going to make it larger than 0, right? So unless we have no weight, we're not putting any weight on it.
W is weight.
W is weight. L is the length of this beam. You'll notice on our E3 and our E4 that we have supports about every 4 inches.
Right.
Right. That's to make L small, because in this equation, these numbers we want to keep small on top. The smaller they get, the smaller deflection. And if you remember your fraction math class, if this number gets large, that number also gets smaller. So we want these numbers to be small. Weight we want to be small, so if it's less load, you're going to have less deflection. Or if you can support that beam all the way along, and some of your CNCs actually have fully supported beams, not this equation, but you keep L small. And then on the bottom you have this E, which is Young's modulus, and let's just talk about that. We want that to be large.
Okay.
All right?
Yeah, so I'm going to act like I understand what he's talking about.
Here's some values for Young's modulus, or what we call E in the engineering world, right? Plywood, 1.5 to 4, average of 2 maybe. Aluminum, 70, so it's stiffer than that. And then steel is 215 times, or 250 gigapascal, so it's maybe 100 times stiffer than plywood. So, wow. If you're going to make a machine and you want it to be rigid or stiff, then by all means you go to steel, voila, you're done. However, there's this other thing called I, and that's the beauty for me of engineering, because I gives me the opportunity. What is I? Good question. What is I? Right on cue. I is geometry.
Oh, jeez.
Yeah, well,
it starts with a G.
Yeah, not geometry is in the stuff that you had proofs in class. The shape of an object. So maybe that would be a better way of saying it. So you've seen an I-beam, right? You just take a long skinny member and you stick a top and a bottom on it.
Yeah.
That top and bottom make it tremendously more rigid than it would be if it didn't have them.
Right.
I can show you the math of that. It's 1/12 base times height cubed.
I don't want to hear it.
Oh, come on. But anyway, the bottom line is you can make I really big. You can't change steel. Well, you can't change aluminum, and you can't change plywood, even though it has a range depending on the plywood. But what you can do is in the design, which is what I love to do, is change the I.
So you're talking about, with plywood, adding like the box beam construction to stiffen everything up.
Absolutely.
Right.
Putting the support where you need it, so that I is big, and if I is big, deflection is small. It has just as much value as steel. If I have geometry that's 100 times stiffer, right, I can use plywood, it will be as rigid as steel. Now, you would say, well, wait a minute, what if your designs were exactly the same? If your geometry or the shape that you made was exactly the same, then steel would be roughly the 100 times stiffer than the plywood, right? If it was 2, and this was 200, right? So yeah, but that's not the case, right? The case is for me, design matters. Yeah, material properties are important, and you can gain a lot, but you can also gain a lot by the eye. And so, what is BobsCNC all about? When we design
cost-effective design.
Simple, cost-effective design. Let's use a material that we can work with. It's easy to manufacture, that our woodworking fans will love, because they can modify it because it's wood and that's the tools that they have. And so what we have to do, we have to make I big. Now, I want to be clear, and we tell this to our customers all the time. If you're looking for a production machine, move along. You don't want an E3, E4, or KL7 series, right? It is not made for production. If you're looking for a production machine, I would recommend that you start at somewhere around 5,000. That probably won't do it. Probably want to get into the $10,000 to $50,000 for a CNC router that will do production stuff. However, if you don't need to crank one out every 15 minutes or every 15 seconds, depending on the part.
So by production, all you're saying is you've got a machine that is so rigidly designed you can push that router through the material.
This can be bigger.
Okay.
The weight, the load that you can put it on.
Okay.
Right? With ours, if you keep the W within the parameters of what we recommend, I tell people to start off with 20 to 25 inches per minute with a plunge of about 8 to 12 inches per minute, and then let's do a max depth of cut of a 1/16 of an inch or a little bit more, maybe 0.08 inches. You're going to be fine. Your machine is going to be designed so that deflection is small enough within a few thousandths, so that your projects are going to turn out really nice.
So you're saying that when we cut within the parameters, the speed and feed that the machine is designed for, that it'll hold what, about 5,000?
Yeah, it would do that. Yeah, for a well-maintained belt machine, sure.
Okay, now that being the case, I mean, from a woodworking point of view, and this is the thing that I wanted people to understand, is that we're not claiming to be Mazak and we're not claiming to be Bridgeport, but we're saying that in the woodworking world, if you're holding 5,000, dude, you're golden.
Yeah.
And now this intarsia work you used to do, a lot of hand-cut inlay, and you've done some really exquisite stuff. And you say you did this stuff by hand. And not a router, I mean you did it by hand.
Yeah, I had a CNC back then.
Yeah.
It would have turned out a lot nicer. Yeah, I probably held 10 or 30, 40 thousandths, maybe a half a millimeter or so, right? But there was a lot of, each piece took, hours of shaping and getting right, or throwing it away and starting all over. Whereas a CNC router, you would be able to program that and not just make one, intarsia. You could make, one every day.
Right.
Right. You could use all your scrap wood, and it would be that'd be awesome. I should do that. I could start a business. Oh wait, I already did that.
I don't think you have enough time. Well, guys, if you have any questions that you want to ask either Bob or me about what we're doing here at BobsCNC, you can contact us at, good Lord, that showed up, shoptalk@bobscnc.com.
Kristen's got it together, huh?
Yeah. Well, I guess we started to pay her.
Yeah.
But anyway.
Hey, by the way, did you hear Congress got a raise?
Oh, jeez. This is so lame. They do just about as much as Bob, too.
Oh,
no, actually, I think you do more than Congress.
Yeah, I think so.
And I think you would deserve a raise. I'd love you to have a raise.
Okay.
Yeah.
I don't agree with the raise.
Okay, but in any case, till next time, guys, we hope to see you soon, and be safe as you're working on your projects.
Bye, guys.